Take a look. You can see it. All right, in the day 2 notes, we studied translations. That's the left, right, and up, down shifts. Recall that the logarithmic parent functions have a vertical asymptote at where? We just talked about this 3 times. Where's the x equals 0? Good job. When a logarithmic function is translated horizontally is left or right, the vertical asymptote translates the same amount and the same direction. When a logarithmic function is translated vertically, that's up and down, the vertical asymptote does not change. So that's just a quick recap of yesterday. Today, we're going to look at a vertical stretch, vertical shrink, and reflections. So consider the function f of x equals 1/2 log base 3 of x. What is the equation of the parent function? Who can tell me? Yeah, Avery? Yeah, log. Now the way we read it is log base 3 of x. That's a base, okay? So we're going to read that as y equals log base 3x. All right. What is the domain of all parent functions of logarithms? It's all the same before we do our shifts. Nice job. It's 0 to infinity. The asymptote is x equals 0. Make sure you're writing an equation. So it's x equals 0. And the range is negative infinity to infinity. If you have your graphing calculators, go ahead and grab them. I think I've got, let me remind you about my charging station. The back 5 you may borrow. Anything in the front 5, those are students that are charging theirs. Do not ever take another student's calculator. So back 5, you just have to put your cell phone in a slot and you can borrow it so that I get them back. So let's go ahead and let me know if you need any help with the buttons, but I think we did a fantastic job yesterday learning how to enter logarithms on our calculators. So fill in the table. So again, if you need a little assistance, this would be log base 3 of 0, and something weird happens there. What does your calculator say? Undefined. And that's why the domain is a parenthesis and not a bracket. Let me say that again, because this is really important, and I've had students in office hours and math lab asking good clarifying questions. The domain is not a bracket at the 0 because it's undefined. We have to wait a little bit till next week to figure out really the why behind that. But for now, we're just going to trust the calculator. The log base 3 of 1, what did your calculator spit out? 0. Log base 3 of 3. Is anybody noticing the pattern here? What's the pattern? What appears to be happening? Yeah, Wyatt?
So the y is 3, or x equals the y to the power of,
the base to the power, right? Yeah, you've got it. So watch this. If you think about it, 3 to the y power is the x, right? 3 to the first is the x. 3 to the second is the x. The 3 to the third is the x. So it's sort of like going backwards, but hey, isn't that what an inverse of an exponential is? It's going backwards, right? It's giving you the x value is the answer to that exponent. All right, so a logarithm. So let's go graph this before we do the end behavior. And I do want to mention, I'm not trying to be mean-spirited at all on the homework, but a couple of you, I gave you a 1.9 out of 2 because you did not draw your asymptotes. the asymptotes are part of a logarithmic graph. So please make sure you're doing that, and just taking 1/10 was a teeny tiny amount to get your attention. So I'm going to draw the vertical asymptote. X equals 0 is the y-axis. It's a vertical line. So I have 1, 0. Hey, that's my x-intercept. Do we need that anywhere? That is the x-intercept. Then I have 3, 1, 9, 2. Make sure that you go all the way down, approaching negative infinity. So as x approaches 0, y goes down to negative infinity. And as x goes to infinity, it's going up to positive infinity. All right, so that is the parent function, and that's what we learned yesterday. So today, we're going to look at now f of x is 1/2 times this logarithm. What transformation is that? What we learned previously. Good job. That is a vertical shrink of 1/2. So this is a vertical shrink of 1/2. In mapping notation, vertical is your y. Okay, vertical is up and down. Vertical is that y. So my mapping notation is x, 1/2 y. So domain is your x values. Did anything change for my x in the mapping notation? No, so my domain didn't change. So my domain of this new function is 0 to infinity. Now let me ask you a question. If the range is negative infinity to infinity, if I move it up and down, does that impact negative infinity to infinity? No. If I multiply by 1/2, does that impact negative infinity to infinity? No. The range of all logarithmic functions will be negative infinity to infinity. What is the equation of the asymptote? X equals 0. When is the only time, what transformation is the only time that it's going to change the asymptote and domain? Left, right. Left, right. That's not vertical. Vertical is the up, down, but it's a left, right. Okay, so here we go. I'm going to take this mapping notation. Nothing changed with the x. So we're going to recopy the x values. Now undefined stays undefined. But what am I going to do to the other y values to get the new ones? Multiply them by 1/2. All right, well 0 times 1/2 is still 0. Then I get 1/2. 2 times 1/2 is 1. 3 times 1/2 is 1 1/2, 1.5, 3 halves, however you want to call it. It's the same thing. It's like my husband's name, Tom, Tommy, Thomas. It's all the same. Okay, so let's plot this. So my vertical asymptote didn't change. And my x-intercept didn't change, right? It's still 1, 0. But then I went to 3, and then it's 1/2. 9 is 1. So let's do our end behavior. That didn't change, did it? The end behavior didn't change. So as x approaches infinity, y is going down to negative infinity. And as x approaches infinity, y goes to infinity. All right, what clarifying questions do you have with, say, end behavior, just that piece? You understand what it means as you move your graph closer and closer to where x is 0, where's the graph curve going? It's shooting down. As I move to the right, where is it going? Ever so slowly, it is increasing. All right, how would the graph be different if the transformation was a vertical stretch of 2 instead of a shrink of 1/2? Yeah, Davey? Yeah. No, not always, because, and we're going to see this, if I do a reflection over the x-axis, it would flip it up, and approaching x is 0 would go to positive infinity. So I can, with a transformation, I can flip it. Great question, though. It's good trying to summarize there. All right, let me get back to this question. How would the graph be different if the transformation was a vertical stretch instead of a shrink? What do you think that would do? Yeah. It would be, how do you want to say that? Twice as tall vertically, I guess. So here's what I would like you to do. Grab your graphing calculators, and I'm going to do this as well, but I want to give you a brief head start. On your graphing calculator, go to a graph page and type in y equals 2 log base 3x and y equals log base 3x on the same screen. And if you've never done two of them at the same time, here's what you do on the TI Nspire. Put the first one on, and then you hit tab, I think twice, and it puts the second one on. So let me see, here's mine. Let me pull mine up. So, since most of you have the Nspires, let me do this. So I'm going to add a graph. So I'm going to do 2 log. This is base 3x. I press enter. Then you hit the tab. And I'm going to do the log base 3x. Ooh, isn't that cool? So the 2 times, you see my blue one is the 2 times, so it is taller, okay? It is taller out there. All right, any questions on that one? All right, let's do example 2. It says, consider the function g of x equals negative log base 3x. This has the same parent function as example 1. But what transformation does the negative out front do? What kind, Keller? It's actually over the x. When it's on the outside, that's a reflection over the x-axis. Let me show you what it would look like to be over the y-axis. Oh, thank you. Okay. So that's a reflection over the x-axis. This one, if I replace the x with a negative x, okay, this is how you would do a reflection over the y-axis if you replace the inside x with a negative. Okay. So, the mapping notation is x negative y, because I put that out front. If it were inside, that's where the x would become negative x, but that's on the outside, so it affects the y value. So I already copied the parent function points for you from example 1. And now what I want you to do is I want you to send it through the mapping notation and give me the new table. If you're a fast worker, plot it. value stayed the same. So the domain, I didn't move it left or right. Okay, I did not move it left or right. So the domain is 0 to infinity. That means the equation of the asymptote stayed the same as the parent function. Nothing is, no matter what transformation you do to a logarithm, it's still eventually going to get to negative infinity to infinity. So I'm going to sketch my vertical asymptote. That is a requirement to the graph. Then I'm going to do 1, 0. Then it's 3, -1, 9, -2. And keep in mind, it's being reflected. So hopefully you can see how that piece that normally went straight down is getting flipped upwards. So then, Davey, you asked an outstanding question because now we're going to see it right here. So then when I do my end behavior, as x approaches 0, y is actually going up to positive infinity. And as x goes to infinity, y is eventually going to go down to negative infinity. All right, questions on this one? Not too bad, right? I mean, this really is all the same transformations we've been doing. All right, the last thing, we're not going to actually make a sketch, but we're going to do this on our calculators. What would you expect, and I kind of blew the surprise here, what would you expect with y equals log base 3 negative x? What should happen? Good job. That is a reflection. Let's write it down. Oh, we'll do it here in the transformation. Sorry. That's a reflection over the y-axis. So I'm going to pop my graphing calculator back up. And I'd like you to do this on your graphing calculator as well. And I'll come back to this screen. But if I go and pull up a new graph, and I do, this was log base 3, but I want negative x. Ooh, super cool, okay? Can you see this? It normally goes like this, okay? You can look at the board with me. It normally came up like this, and now I reflected it over the y-axis. So, ooh, I think I wrote the wrong domain down. Just caught myself. What's the domain? It's not 0 to infinity. That's to the right. Negative infinity to 0. Okay, whoops. Oh, I didn't write it yet. Oh, good. Okay, so the domain then is negative infinity to 0, but it still goes up and down forever. The asymptote didn't change. When is the only transformation that's going to change the asymptote? Left and right. So I can do all the reflections I want. I can move it up and down. That does not change the asymptote, only left, right. All right, so let's make just a teeny tiny little sketch like this, just a little rough sketch. And let's see if you can fill in the end behavior. As x approaches 0, where does the graph go? Where does the y value go, Lilia? Nice job. It does go down to negative infinity. And when, oops, I gotta change that. When x goes to the left to negative infinity, where does the graph go, the y value? Positive infinity. There we go. All right, what questions can I answer before you tackle your homework? Anything you need to clarify?